What is a DDoS attack? A distributed denial of service. D attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming it with a flood of internet traffic. This is achieved by using multiple compromised computer systems as sources of attack traffic. These compromised systems could include computers and other networked resources such as Internet of Things IoT devices. How DDoS attacks work. In a DDoS attack, the attacker typically follows these steps. 1. Compromising devices. The attacker first gains control over a large number of devices. This can be done through various means, such as malware infections, vulnerabilities in devices, or by exploiting insecure configurations. These compromised devices are referred to as a botnet. 2. Launching the attack. Once the botnet is established, the attacker instructs these devices to send an overwhelming amount of traffic to the target server or network. The target is unable to handle the massive influx of data, leading to disruptions in its services. 3. Service disruption. The target server, overwhelmed by the traffic, slows down or becomes completely inaccessible to legitimate users. This disruption can last for minutes, hours, or even days, depending on the severity of the attack and the target's ability to mitigate it. Types of DDoS attacks. DDoS attacks can be classified into three main categories based on the part of the network they target. 1. Volume-based attacks. These attacks aim to overwhelm the target with massive amounts of data, consuming all available bandwidth. Example, UDP flood. This type of attack sends large numbers of user datagram protocol, UDP, packets to random ports on the target system, causing it to repeatedly check for applications listening at those ports and respond with ICMP packets. 2. Protocol attacks. These attacks exploit weaknesses in the protocols used to transmit data over the internet. Example, SYN flood. This type of attack exploits the TCP handshake process by sending numerous SYN requests to the target, but not responding to the SYN-ACK replies, causing the server to wait for responses that never come and eventually run out of resources. 3. Application layer attacks. These attacks target specific applications or services on a server. Example, HTTP flood. In this attack, the attacker sends a flood of HTTP requests to a web server, overwhelming the application layer and causing it to crash or become unresponsive. Real-life examples of DDoS attacks. 1. Dynattack 2016. In October 2016, a massive DDoS attack targeted the DNS provider Dyne, causing widespread disruption to major websites such as Twitter, Netflix, and Reddit. The attack was launched using a botnet primarily made up of IoT devices infected with the Mirai malware. 2. GitHub Attack 2018. In February 2018, GitHub, a major code hosting platform, was hit by the largest recorded DDoS attack at the time. The attack peaked at 1.35 TBps and lasted for about 20 minutes. It was a memcached amplification attack, which exploited an improperly configured server to amplify the amount of traffic sent to the target. 3. Estonian cyber attacks 2007. In 2007, Estonia experienced a series of DDoS attacks targeting government, financial, and media websites. The attacks were politically motivated, allegedly in response to the Estonian government's decision to relocate a Soviet-era war memorial. The attacks disrupted critical services across the country for several days. Concepts associated with DDoS attacks. 1. Botnets. A botnet is a network of compromised devices controlled by an attacker. Each device in the botnet is called a bot or zombie. Botnets are the primary tool used to launch DDoS attacks because they can generate vast amounts of traffic from multiple sources simultaneously. 2. Amplification. Amplification occurs when the attacker uses a small amount of traffic to generate a much larger amount of traffic towards the target. This is often done by sending requests to open servers, such as DNS or NTP servers, that respond with significantly larger replies, which are then directed to the target. 3. Reflection. Reflection involves sending spoofed requests to a third party such that the response is sent to the target instead of the attacker. This technique is often used in conjunction with amplification to increase the power of a DDoS attack. 4. Rate limiting. Rate limiting is a defensive measure that restricts the number of requests a server will accept from a single IP address within a given time frame. This can help mitigate certain types of DDoS attacks by preventing a single source from overwhelming the server. 5. Anycast network. Anycast is a network addressing and routing method in which multiple servers share the same IP address. Traffic is routed to the nearest server based on network topology, which can help distribute and mitigate the impact of DDoS attacks. Mitigation techniques for DDoS attacks. 1. Firewalls and web application firewalls, WAF. Firewalls and WAFs can filter incoming traffic and block malicious requests before they reach the target server. They are particularly effective against application layer attacks. 2. Load balancing. Load balancers distribute incoming traffic across multiple servers, preventing any single server from being overwhelmed by traffic. In the event of a DDoS attack, load balancing can help maintain availability by spreading the load. 3. Traffic filtering. Network providers and content delivery networks, CDNs, can filter out malicious traffic before it reaches the target. This can include blocking traffic from known malicious IP addresses or implementing rate limiting.